Hello everyone, in this video we are going to talk about the properties of perfect square numbers. So let's start with the first property. All the perfect squares are either 0 or positive numbers. Let's try to understand this. Square of 0 is 0. Square of a positive natural number 2 gives us the answer 4. Now let's take one negative number. So square of minus 2 also gives us 4. So here we can clearly see that doesn't matter whether you are taking a positive number or a negative number, its square will always give us a positive number. Now the second property is square of an even number will always be an even number and squares of odd numbers gives us odd numbers. Let's take random examples here. Let's take an even number 4. So the square of 4 is 16 and 16 is also even. So when we take even number here, our result is also even. Now let's take one odd number 3. So the square of 3 is 9. So when we take odd number here, its square is also giving us an odd number. So that's why we have this second property, that the square of even numbers are even and the square of odd numbers are odd. Now let's look at the third property. Perfect squares never end with 2, 3, 7 and 8. So if you are given a particular number, for example 122, and if they are asking you to check whether 122 is a perfect square or not, so you don't even have to go for the prime factorization method. You can clearly see here that 122 ends with 2. So definitely this is not a perfect square. So without testing it using the prime factorization method, just using the property, we can simply say that this particular given number is not a perfect square. Now let's talk about the fourth property. So if we take two consecutive natural numbers n and n plus 1, and if we find out their squares, then there will be total 2n numbers between the squares of these two consecutive natural numbers. Let's try to understand this with an example. I understand that this property might be difficult for some students to understand in just one go. So let's understand this with an example. It will be more clear. Let n is equal to 3. Then definitely our n plus 1 will become 4, right? Now let's see n square, which is 3 square and 4 square. So 3 square gives us 9 and 4 square gives us 16, right? Now what all numbers are there in between 9 and 16? So we have 10, 11, 12, 13, 14 and 15. Yeah, so we have these numbers between 9 and 16. If we count the numbers, we have total 1, 2, 3, 4, 5, 6. So total 6 numbers we have, right? When we talk about the numbers which are lying between two given numbers, means we have to exclude the extremes. So we have to exclude 9 and we also have to exclude 16. Means we don't have to count 9 and 16. All the other numbers we are counting and the total numbers are 6, which is equal to 2 into 3, right? And 3 was our n. So if we have two consecutive natural numbers n and n plus 1, and if we find their squares, so there will be total 2n numbers between these two perfect squares. So this is our fourth property. Let's understand the fifth property. Fifth property says that sum of first n odd numbers is n square. Now again, let's understand this property with an example. If we take the first odd number, total sum is equal to 1. If we take first two odd numbers, their sum is equal to 4. If we take first three odd numbers, their sum is equal to 9, right? Now, if you see the pattern, this 1 is equal to 1 whole square, this 4 is equal to 2 whole square, 9 is equal to 3 whole square. Now, repeat this for one more row. 1 plus 3 plus 5 plus 7 gives us 16, which is equal to 4 whole square. Now, can you understand the pattern? Can you analyze the pattern? So, when we have sum of first one odd number, it is equal to 1 whole square. Sum of first two odd numbers is equal to 2 whole square. Similarly, if we take the sum of first n odd numbers, then it will be equal to n whole square. And exactly this is what our fifth property is telling, that the sum of first n odd numbers is n square. I hope this property is also clear to you. Now let's move on to the next property. Now the next property says that a perfect square never ends with odd number of zeros. So now if you are given a number like 1000 and they ask you to check whether this is a perfect square or not, again you don't have to go for the prime factorization method to check. You can simply use the property that 1000 ends with 3 zeros and 3 is an odd number, right? So this is ending with odd number of zeros. So definitely this is not a perfect square. Okay, let's also verify this using the prime factorization method. Let's see what we get when we do the prime factorization of 1000. So here 1000 can be written down as for this 2, we can create a pair. For this 5, we can form a group. But we can clearly see that this 2 and this 5 are left alone, right? So that's why we can say that 1000 is not a perfect square. So this we have verified using the prime factorization method, but we don't really have to waste our time. Simply using the property, we can say that because it is ending with 3 number of zeros, so it is not a perfect square. Thank you so much for watching this video. I really hope this video helped you understand the properties of a perfect square. For more such educational videos, follow, like and subscribe to our channel.